So, hello everyone. As you just heard, my name is Henrik. I'm a test automation developer. Uh, Everyone that knows me know that I keep nagging about how important it is to add more test cases, how important it is to automate as much as possible. And you all know, doesn't it work?
It works. Close it from now.
Oh, now?
Yes. Yeah.
Oh, it works? OK, great. Yeah, what was I saying? Yes, we want to automate as much as possible because, you know, our QA can't spend all days testing. Oh, I actually just realized that that's exactly what they do, but they only have 8 hours, like all of us. They only work 8 hours, so they still need time to focus the testing on what's important. So today I'm going to show you how GitLab CI works. It's a continuous integration environment, a very strong base for you to run all your tests and builds on.
Hold the microphone in front of your mouth.
I feel like I'm basically putting it inside of my mouth. OK, can I maybe increase it? OK, I'll try. Yes, because without a strong base, no matter how good your test cases are or your test builds, you will get less value because you're running on an unstable system, and you probably get lots of false positives and test results that are unexpected. So in the end, this is all about keeping the system stable. And in the very end, it's all about saving time, precious time that can be spent elsewhere. So this is the agenda for today. I'm going to first show you an overview of the whole system. Then I'm going to go into more details, like what hardware you need and how you set it up, and also the configuration you need. And in the end, I'm going to show you some results. There are some configurations we have been setting up and how it looks like. So we're going to start off with the overview. Here's the most essential part of GitLab CI. Everything just starts with a commit, and then it's followed by a pipeline. In this case, the pipeline is split into a CI pipeline, a continuous integration pipeline, and a CD pipeline, continuous deliver pipeline. The continuous integration pipeline is anytime you merge small chunk of code into your main chunk, you want to verify that it hasn't broken anything. So this pipeline should be run every time you do changes to your main chunk of code. And the CD pipeline, the continuous delivery pipeline, are utilized when it's time to deliver or deploy. For example, when you build your MSI file. But today's focus is going to be on this part, the CI pipeline, because that's where it all starts. And I want to focus on the basics. Once you know the basics, you probably figure out the continuous delivery pipeline and how that works too. So no point in me showing you how to do it. Better to let you figure out yourself, I think. Yeah, this is how it all works. We have a GitLab server, and then we have our runners. A runner is just a machine, any machine registered to the GitLab server. And when it's registered to the server, it can pick up jobs whenever there is jobs available. A runner can be any machine. It will be coordinated by the GitLab server as long as it's registered. It can be a big server that can run many concurrent instances. Or it could be something very simple, like your laptop. I strongly recommend you to not use your laptop, because the connectivity on those machines are usually worse, and the performance are also worse. So I suggest you to at least use a desktop computer. At the GitLab webpage, we have a pipelines page where you can see everything going on, like all the jobs running, and you get a quick overview of the general system stability. At times, it can be a very joyful place to be in, just watching everything goes green and you see everything goes well and fine. At Other times, it could be like watching a comedy movie, even a horror movie at some points. In this example here, we have a pipeline with 3 stages and 3 jobs. A very simple but yet very powerful one. You can actually see the stages here, here, and here. So a compile stage, a test stage, and then a merge stage. Each stage has 1 job. This means that the compile job will run first, and then the test, and then after that the merge. Of course, you can put multiple jobs into the same stage, but instead of running sequentially, those will be running in parallel instead. So this is all you need to set up GitLab CI. First, you need the so-called runners, which is just any computer registered to the GitLab server. And the GitLab server will coordinate jobs to this machine. And this is a very scalable design, because whenever you need more hardware, you can just register more computers to the server, and jobs will be distributed to these computers too. Then we also need a configuration, where we define the jobs. Jobs can be builds and tests, but honestly, anything you would like it to be, but it's mostly used for builds and tests. And then we have different types of triggers. Like you can trigger a job on every push. It could be on merge requests. It could be on schedules. Then there are, of course, a lot more triggers, but this is the most common ones. Yeah, here you can see a main branch, which is our main chunk of code, and then a feature branch, which is the new feature we want to add. The suggested workflow from GitLab CI, or at least it used to be the suggested workflow, but it might have changed lately, is to first run the pipeline on the feature branch, then merge it into the main branch, and then run the pipeline again. But I know many of you here are developers. You know that if a test goes green and it works on a feature branch, it doesn't guarantee you that it will work when merged together with the main chunk. So even if the test passes at the feature branch and then you merge it, yes, you will find out later on that it doesn't work because you run the test once again. But for me, that's already too late, because you might have ruined the day for one of your colleagues already if they happen to branch out at that specific point. So how we are doing instead is we always work through merge requests. And inside of merge request, we always merge the main branch into the feature branch, but only locally on the runner machine. So we basically simulate the final result before actually running the test. So you always run on the final result. And once it merges into the main branch, it should always keep the main branch green, so you won't ruin the day for any of your colleagues. And yeah, this is the way we have been utilizing for half a year now, and it has been working well so far. And talking about the merge requests, this is how the merge request looks like when everything goes well. You can see that everything looks green here. The pipeline is green, so all the tests and builds have passed. Even this one turns green, and you see here that you have a green checkbox here, and the bottom is green. Compared to when something is failed, you see that it's all red. You also have a warning sign here, and the merge button is red. It is actually possible to click the merge button, even though it's red. It's a bit bad, but that's how it is. But when you see it's red, you really shouldn't click on it. So now let's go on to see how you set up the hardware. First off, you need to log into the machine you want to use as a runner. Then you go to this webpage at gitlab.com. Let's go to the CI/CD page. To do this, you need to have at least maintainer access of your repository or project. And then just follow the step-by-step guide. I want to point out that you should pick the AMD 64 binaries, even if you're running on an Intel machine, because I got some questions regarding this before, so I just want to point it out. Other than that, just follow the step-by-step guide and do all the steps it's asking you for. Yeah, one more thing is the information you need to set up the runner is actually on the first page. But once you click on the install GitLab runner, you will get to another page. So save this information before you go on. And then just follow the guide. The text is very small. You probably can't see it, and the red lines are back. But it doesn't really matter, because I just want you to recognize this page so you know where to go later on. And yes, the information is on the first page. When installing the runner on Windows machine, you need to remember to put a username and a password for a real user. If you don't put this, it will put you into the system local account. This used to cause lots of problem when we're running our runners on the system local account, because yeah, it was missing some stuff and it just didn't work. Well, we have been fixing this lately, and it might work on this account. I still strongly recommend you to use a real user account when installing your runners. And if you forget to do this or mess up during installation, you can always go to the service page here on your Windows machine and just go to the specific service and click properties, and you can fix it later on. Here is the page for runners on the GitLab webpage. You can see that on this specific project, we have 2 runners registered. On this page, you can do some small configuration to each runners. You can also pause a specific runner. It's very useful if one of the machines stops failing and you want the GitLab server to distribute the jobs to another machine, so you stop getting these random failures. So just pause it and fix it, and then you can just resume it later on with this button here, pause and resume. Yeah, one more thing before we go on to the configuration you need. On each machine you install the runner, you will get these config.toml file auto-generated. In this file, you don't need to do much anymore. Back in the days, you used to need to do some stuff, but nowadays, the only parameter I really change here is the concurrency one. This parameter decides how many concurrent jobs each runner can pick up, or not each runner, but this specific runner can pick up. So if I have the concurrency of 6, I can pick up 6 concurrent jobs on this machine, depending on how strong the machine is, of course. So let's go on to the configuration you need. We have made it very simple for you. First off, we need to create the file .gitlab-ci.yml in the root folder, the root project folder. After that, basically you just need to include our predefined scripts, which you do like here in the code example here. And then just define which stages you would like to use. So we're just going to follow the same example with a compile stage, a test stage, and then a merge stage. And once this is done, we just need to define the job itself. So in this case, we have a test here, and that should belong to the stage bill of material test. And then just inherit from our predefined scripts. If you inherit from a predefined script, you don't need to set up the whole environment to run CT Designer. You also don't need to clean up between each test cases. So this will be done all for you, because GitLab runners, or the jobs, works in a way that you should set up everything at the beginning of the job, and you should also clean up everything after a job, and then set it up again for the next run. It's done that way because you don't want jobs to affect each other, so you should always run from a clean state. And then we have the script itself. As you can see here, it's just one single row, and that's basically all you need to run a test. I will explain what exactly these rows mean in the next slide, but for now, just remember how little code you need to write. And then we have the only parameter in the very end. This one decides when this job should be triggered. In this example here, this job should only be triggered in merge requests. But of course, you can change this up and run it on all commits and all commits you push, or yeah, you can change it as you want. Remember this row from the last slide and the script part? You see that we use something called cop, which is the command line version of our CT operator. And you may recognize this view here. It comes from the build central that you probably have seen before. So you just take the same ID here in your custom build items that you have defined for build central, and just reuse it, put the ID here, and this job will be running on your runners. Yeah, just want to highlight the ID because that's the most important part. And before you're ready to run, you also need to set up a variable. So the CI base branch is like which core you should run against. This variable can be set up locally inside of each job, or globally at the variable page at GitLab or git.configure.com. So depending on if you want specific branches for each of your job, or you just want a global one that you run all your jobs against. Can you see anything? Don't say yes. There's no point in trying. I put it this small for a reason, because I don't want you to see. The thing is, if you choose to inherit from our script, this is all you get, and that you don't need to set up on your own. Let's just go back a few slides, because you see, this is all the code you need to use if you decide to inherit from our predefined scripts and use the predefined jobs we have, instead of doing all this. For me, it would be an easy decision. I don't know about you. So yeah, use our predefined scripts, at least in the very beginning. Once you master the basics, you can always set this up on your own. But if this is the very first time you do this, I would just recommend you using this. Just inherit from a script, write what you want to test, and then go. And here is the final result. You can see that now we have, instead of just this job, we have 1, 2, 3 jobs. And this is the result here on the GitLab webpage. And then, of course, it's possible to get details of each job by just clicking them. You can also press this button to rerun them. But this is how it looks if you click into one of these. In this example here, we have been clicking on this one here, the bill of material test. And you see that we get into this page here with all the details. So you can actually follow all the steps that runner has been doing, like which files it has been cleaning up, which folders it has been, or which projects it has been cloning, and so on. And you can also download the artifacts. Artifacts in this case is like log files and all the kind of stuff you need from the write folder to debug your results. yes, this is how it looks. If you decide to download the artifacts, you can see that there is CM log files for each test that has been running in this test run. So just a quick summary of exactly what this does. So first off, the predefined script will set up the variables to run CT Designer. After that, if you are running in a merge request, it will also merge the merge request, simulate or do a simulation of the merge. So you actually run, once you run the script in the next stage, you will actually run on the final result of the merge request. And in the end, it will also clean up so you are ready to run the next test and also upload the logs. Yeah, before I show you some examples, any questions so far?
I have one question.
Yeah, sure, you are.
How you said you want to merge in the main branch to the feature branch because
it's not really merging it, but just doing a simulation
like
of it. Yeah, exactly.
Like mock merge kind of thing. How does that work with the scaling of the project? That kind of makes me think that you can only run one of these runners at the time, because all the others are dependent on the previous merge succeeding, right?
So what you're talking about is basically like if you set up two merge requests, it will merge the target, but you won't include the other merge request, right?
Yeah.
Yeah, I mean, that's a case where you can actually sneak in error into the system.
Yeah, okay.
But
so they do run in parallel, and they
yes,
don't
yes.
take each other into account, but it's like a fringe case.
Yes, but it's still a very minor risk, because compared to otherwise, you have to ask all your developers to keep updating their feature branch. You always have to merge target into your feature branch before you set up the merge request. But you know, we're all developers and we don't want to do that much.
Yeah.
We want to do the least amount of work we can do to get through. And yes, that's actually one way of sneaking errors into the system. So it's very dangerous to have merge request that lays around for too long for that exact reason.
Yeah.
But it's still a very minor reason comparing to asking all the developers to keep updating their feature branches all the time.
Yeah, true enough.
Oh. Any more questions?
How if we run this the predefined script?
Yes.
Is it gonna be stable? I mean, are we gonna get any false positives that you know of? Because I remember
From the predefined scripts itself?
Yeah, because I remember we had some issues with doing merge requests to the base package, and we get like the red service or something, you know, throws a false positive, and the merge is actually okay, and then you just have to run it all again. Are those things?
Yes, but that's on the test level.
Yeah.
So it's not really on the. This just sets up all the environment you need to. So even if it fails in the predefined script, it's still in the setup phase. So your test won't get read anyway. But
Yeah.
the only one that can actually cause a failure is the script itself.
Ah, okay. Yeah. Fair enough.
Any other questions? Otherwise, I guess just gonna give you a quick overview of how it actually looks like from the web page. So you can see here we are running on all our merge requests. I'm just gonna randomly pick one. Oh, not this one. I'm just gonna randomly pick any merge request. You can see that we are running our pipeline. So in this case, it has actually passed. It looks green as I showed you before. And this is how our pipeline looks like. We have decided to run many jobs in parallel, so we can run them concurrently and save some time because we have the available amount of runners. so we have resources to run them all at the same time. Then we also have we have the pipeline page where you can look into only the pipelines that has been running. And you have all the history here as well. You can scroll back very... And specific, and this is how it looks like inside the detailed view. You can see that I'm basically building everything here. And you see each package build and how long it took to build it. You also have the possibility, as I mentioned before, to browse and download the artifacts. Like you can get all the build logs here. If you want to look into the details, just download them. And yeah, any more questions?
I have another question.
Mm-hmm.
The bill of material test.
Yep.
What does that do?
Honestly, I don't know. I just borrowed them from one of our customers. I don't have exact details, but I assume that it tests build of materials. Yeah, talk to Rolf afterwards, please.
Yeah.
Yeah, otherwise, I would like to thank you so much for your interest and attention, and hope you enjoyed and will use this system in the future. Thank you.